Delhi draws water from Tehri Dam, which is 300 kilometers away, while Hyderabad fetches water from Krishna River, 116 kilometers away, and Chennai gets water from 235 kilometers away. Cities are becoming thirstier, and a singular response to quench this thirst is to hunt for water sources further and further away. India is home to more than 290 million city dwellers, and this number is only going to grow. Also, as India seeks to propel itself into an urban industrial powerhouse, its industries will need more and more water. This is going to put further immense pressure on the already strained water supply systems of urban areas. 80% of all water that is painstakingly supplied to households leaves as waste. So, do cities require more water, or can they learn to manage their water better? Yes, Bengaluru gets it right. It is recycling its wastewater and reusing it for meeting non-potable requirements of the city. Let's see how.
स्वच्छ भारत का इरादा इरादा कर लिया हमने देश से अपने ये वादा कर लिया हमने स्वच्छ भारत का इरादा कर लिया हमने देश से अपने ये वादा कर लिया हमने स्वच्छ भारत का इरादा
Home to 8.5 million people, Bengaluru is one of the fastest growing cities in India. A city of lakes and a city of aspirations, this picture of a beautiful life cracks the moment you inquire about the water supply in an area from those already living there. Bengaluru, like most cities, was headed towards a severe water crisis. Its location in a semi-arid region makes it naturally water scarce. The Bengaluru Water Supply and Sewerage Board is the statutory organization in charge for supplying water and sewerage services to the city. The city draws 1,350 MLD water from the river Kaveri from a distance of almost 100 kilometers. The board spends 60% of its entire annual budget towards just bringing the water to the city's periphery. Almost 1,000 MLD of wastewater leaves the city as sewage.
Bangalore demand was never satisfied. The current demand is about 1,600 MLD, and we are supplying about 1,400 MLD of water. There is a gap of about 150-200 MLD. Most of this gap is met out of the groundwater within the city and as well as the wastewater.
There's something unique about Bangalore. It gets its water from the river Kaveri, which is about 95 kilometers from the city and about 300 meters below the city. So what happens is that the water which is brought to the city is very expensive. It costs about 82 rupees a kiloliter. And currently there are no projects to bring any other freshwater resource. The city is growing, the population is growing, and the economic demand for water is growing. So we have to find alternatives. One of the alternatives is rainwater harvesting, but the other more tangible alternative is wastewater. And if you're able to treat wastewater and reuse it within the city, there's a large scope for it to replace the current fresh water coming from the Kaveri.
Bengaluru has established 4 tertiary treatment plants that produce 73 million liters per day of close to drinkable water. These treatment plants use different technologies and provide water that is then put to different uses. One of them is the biggest tertiary treatment plants of India, set up in Vishavati Valley or V Valley. The Vishavati Valley or V Valley tertiary treatment plant has a total capacity of 60 MLD and treats 10 MLD water per day. The V Valley treatment plant was funded by the Housing and Urban Development Corporation of India under the Mega City Scheme and by the Indo-French Protocol. Operation and maintenance of the plant is managed by the French firm Degremont Suez.
One of the biggest recycling plants in India. The capacity of the plant is 60 million liters a day. Essentially what we do here is tertiary treatment of the secondary treated sewage which is generated in 180 MLD STP, which is located adjacent to this plant.
The secondary treated water is pumped to the trickling filters. From here, the water then flows into a unit called the denser DEG unit, which is a patented technology of the firm. This unit treats the water through three processes: coagulation, flocculation, and clarification. The water then goes to the pre-aeration tank to raise the dissolved oxygen level in the water. The water then reaches the flowback unit. Here the bacteria in the sand medium eat up the organic matter, and the finer particles settle in the sand. The treated water then goes to the filter water storage tank. The water is then disinfected with chlorine and is now ready to be sold to industries. The capital cost for the 60 MLD treatment plant at V Valley was Rs 12 crores. The plant is able to cover the O&M costs of the plant of Rs 4.7 lakhs per month through sale of treated water to the industries. Another major requirement for water in Bengaluru is for irrigating its gardens. The tertiary treatment plant at Cubbon Park provides water for maintaining the Cubbon Park.
Their borewells were dry. Then they approached the BWSSB whether BWSSB can provide a very good quality wastewater, treated wastewater for their horticulture purpose. Then BWSSB, with the funding from Bangalore Development Authority, they came up with a 1.5 MLD state-of-the-art treatment plant.
The tertiary treatment plant in Cubbon Park uses the membrane bioreactor technology for treating wastewater. The plant is fully automated. The operation, monitoring and controlling is carried out by SCADA system. The water comes into the plant from nearby areas like Vidhan Saudha gravitationally into the raw water wet well. The pumps in the raw water wet well pump the water into the 6 mm screen. Here solids like shampoo sachet, plastics etc. are removed and the supernatant is sent to the common chamber where degridding is carried out. Here heavy particles like stones and gravel are removed. The remaining water is then sent to the 0.8 mm screens, which are able to remove particles of width of human hair. The water then flows to aeration tank. The bacteria in the aeration tank consume the organic matter in the presence of air and get concentrated. This is then separated by membrane cassettes composed of hollow process fiber membranes which prevent passage of bacteria and even viruses. The treated water then goes into the disinfection tank where it is treated with sodium hypochlorite. This water is then sent to the ground level reservoir from where it is sent to Cubbon Park. The excess sludge generated is used as manure after drying in sludge drying beds. The 1.5 MLD treatment plant at Cubbon Park was built at an expense of Rs 4 crores, while the O&M cost of the plant comes to about Rs 12 lakh per month. Currently, the plant is able to recover about 50% of this O&M cost through sale of treated water to Horticulture Department for irrigation of the Cubbon Park. It was also critical to improve the quality of water entering lakes, which are important groundwater recharging points. This is being done by the Jakur Sewage Treatment Plant.
One of the ways of protecting lakes is to use treated wastewater along with wetlands to fill the lakes. This has, of course, the consequence of recharging groundwater and then becoming available again as drinking water.
The treated water from the Jakur secondary treatment plant nearby was diverted into the Jakur lake. This water was then used for neighboring villages. To improve the quality of the water entering into the lake, a constructed wetland was built between the lake and the plant. With a capacity of 10 MLD, the Jakur secondary treatment plant presents an innovative integrated urban water management model. The plant pumps sewage from the neighboring area of Old Yelahanka town into the screen chamber. From the screening chamber, the sewage water enters into the degritting system, where grit, sand, and gravel is removed. The screened and degritted sewage then enters the biological treatment unit, which uses upflow anaerobic sludge blanket, or UASB reactor, anoxic tank, and aeration tank. After biological unit, the treated water is then sent to secondary clarifiers. The sludge from the process is dried in the sludge drying beds, and dried sludge is used as manure. After secondary treatment, the treated water is diverted to the wetland. The man-made wetland purifies the water under the action of reed beds. This natural process diminishes the level of nitrates and phosphates in the water and destroy bacteria. The water is then safe to be thrown back in the lake. Over the years, fauna and flora have both considerably developed in Jakur Lake, showing the effectiveness of the treatment. Yet, recent solid waste outflowing and lack of cleaning have led to a deterioration of the quality of the water. Also, maintenance of the wetland is a skill set which needs to be mastered in order to ensure wetlands remain an effective method for treating wastewater. The capital cost of the treatment plant is Rs 10.33 crores and requires an O&M cost of Rs 10 lakhs per month. Currently, the plant does not earn any revenue. However, by replenishing the lake, the plant has provided a safe groundwater source to the nearby villages.
Jakur now is feeding so many lakes and also making such an impact on the livelihood of the surrounding villages, Rachanelli and then other. There is sufficient quantity of water and all the open wells are charged. So that itself is a great level of satisfaction for BWSSB.
Bengaluru has further accelerated its effort to recycle its wastewater. The city has got approval for 4 treatment plants of 440 MLD under the megacity loans. The government is also building new STPs at Koramangala Chelagatta Valley, V Valley, Hebbal and Dodaballa.
In addition to that, we already obtained 5 treatment plants under approval for construction of 5 treatment plants under Amrut scheme, wherein the 33% of the central government aid is coming and 20% is from the state government. Another 47% will be going to be invested from the board.
16 more STPs are being planned to cater to 110 villages, which were merged in BBMP in 2006.
The barriers are 2. There is a technological and financial barrier because it's difficult to treat wastewater and clean it up, and there's a financial barrier because it gets a bit costly. And then there's the psychological and social barrier. The third approach which the city has taken is to mandate wastewater treatment plants for any housing unit more than 20 flats. So this means that there will be close to about 5,000 small wastewater treatment plants which will recycle the wastewater with zero liquid discharge and reuse it within the flat or layout complex. Now in Bangalore, we have a set of apartments called TZ, which actually recycles, blends it with fresh water and drinks it. So we seem to have overcome the psychological barrier at some scale. Another way of looking at it is that treated wastewater is way cheaper than fresh water. So it makes, and we have the technology, as the MBR plant in Lalbagh, in Kaban Park demonstrates. So we have the technology, the finance makes sense because it's cheaper than Kaveri water. How do we make it socially and psychologically acceptable? The way to do it is to fill in our lakes with it, allow it to infiltrate and then take it out as groundwater, making sure that the groundwater meets BIS 10500 standards. Once wastewater transforms itself to groundwater, there is very little objection to drinking it.
A city lives when its lakes and rivers live. Bengaluru seems to have understood that a water cycle and the life cycle are one.